Hello everyone, welcome to this session. So in this session, we will focus on multi-class SVM. In the previous sessions, we have learned the linear SVM and nonlinear SVM, but all of them, we do binary classification because SVM itself is a binary classifier, right? And it doesn't support multi-class classification natively. But however, in real world, many problems have multiple classes. So here, for example, what we have seen before, the handwritten digits recognition. So we need to recognize from 0 to 9, right? And so also another example, for example, music recommendation program, right? So we have some voice and we need to recognize it's classical, it's rock, pop, metal, or hip hop. Right. So these are the multi-class classification. And we hope to use SVM to solve it. So how can we do that? The basic idea is that we try to break the multi-class classification problem, this is one problem, to multiple problems. And each of the sub-problems is binary classification. And for each sub-problem, we can directly use SVM. Right. So we normally have two methods to break the problems. So one of them we call one versus rest. So this means that we separate one class and all the other class I don't care. That is, we call them the rest class, right? And the second is one versus one. So in this case, each time we separate only two classes and the other classes I don't care at this moment, right? So let's see some examples to see how one versus rest and versus one versus one goes. So one versus rest, we have three classes now, right? So first, we separate one class to the rest. I first do this. So this is what? The blue class and the rest of them. So the rest of them, what is composed of? I don't care, right? Blue rest. Then I do the other called what? Green rest. Then I can do the red rest, right? So in this way, I get three SVMs. Each one, we separate a single class and the others. So one versus one, how can we do that? We can see there are also three classes. I first separate the red and the green. So no matter how the blue is, right? Red and green, we separate them. Then we separate the blue and red. Then we separate the blue and green. So we can see the red one was classified to two groups, but it doesn't matter. So each time I only care two classes. So based on these two breaking approaches, so let's see them one by one to see how each of them we train the model and how we predict a new point, right? So we can see this is an example, right? So we have three classes. This is a point we want to predict. Let's see the first one versus rest. So now we have the n class problem. So here is three classes, but this can be generalized to n class, right? So one versus rest, each time we separate one class and the rest class. So in this way, we will train the n SVMs, right? Each one, class 1 vs the not class 1. Class 2 versus not class 2 until class n versus not class n, right? So the n SVMs are trained. So then how can we use them? Before that, I first introduce two concepts. The first one, we call it the positive region. The positive region is a region where the positive class, the 1 over rest, that's the 1 located. So for example, the blue versus rest, the blue is the 1, the positive region, right? So others is the rest. So the others, we call it the negative region, right? So this is the rest. So here we can see this one is from the blue rest SVM. So this is a positive region, right? Because it's blue. And this one is a negative region. So that is a rest, right? Okay. So then based on these concepts, we can make the prediction. So we will use each SVM to predict, and the result is that the one that puts the prediction that the farthest deep into the positive region. So let's see an example and you will understand what it is. So now, these three classes, this is a point to be predicted which class does it belong to. Then I can have the red rest, the green rest, and the blue rest, 3 SVM. Then we will compare the distance. So first of all, we use which one? The green rest, right? So we can see this point in the positive or negative, so in the positive region of the green rest, right? And this is the distance to the boundary. Then we consider the blue rest SVM. So all things is also in the positive region, and we consider the distance to the boundary is here. Then we consider the red rest. So for this point is not in the positive region, in the negative region. Because it's in the negative region, so then no matter how the distance is, it doesn't matter. It won't belong to red, right? And then we can compare these two distances, right? In the green rest and the blue rest, we can see this is deeper into the blue rest, right? So that we predict it into as a point belongs to the blue, right? So this is a one versus rest, one multi-class SVM classification. Then we can see the one versus one. We still have the n-class problems. This time each time we separate every pair of classes. So in this way, this is a combination problem. And if we will know that, we will train the n multiply n minus 1 divided by 2 SVMs. So each SVM, we can say the SVM 1, the class 1 and the class 2, separate them. Class 1, class 3, to class 1, class n, and at the last one, class n minus 1 and class n. So we can divide all of them, right? So using this amount of SVMs, so how can we predict a new point? So we can do like this. We can use each of them as an SVM to do a prediction, right? Then we will have a result, right? So for example, this is a predicted point. So let's use a blue-red prediction. Okay, I predict it to be blue. Then I use a red-green prediction. Okay, I predict to be green. Then I use a blue-green prediction. Okay, I predict to be blue. So then we use a majority vote rule, right? So we can see among the three, 2 of them predicted as blue. Then the result is blue, right? So in 1 versus 1 plus majority vote, we can also do the multi-class classification using SVM, right? So no matter one versus rest or 1 versus 1, so each SVM, we can use a previously learned method to do it, hard margin, soft margin, or nonlinear, right? So now we solved all of the classification problems using SVM. Thank you for listening. Bye-bye.